I welcome you back to Analytics Simplified, and in this series on algorithms analysis and design, I will be taking up another problem on Master's theorem. So, in case you haven't revised what Master's theorem is, I would suggest that you follow the I button and get a quick recap of the theorem. Okay, so in this question, we are given a recurrence equation of the form Tn is equal to root 2 times Tn by 2 plus log n. Now, this is the recurrence equation that we are given, and we are supposed to find out its time complexity by using Master's theorem. So we remember that the first step that we have to do is we have to convert this into the standard form. And the standard form there is a theta notation. So what I will be doing is, in order to introduce theta notation, I call this function log n to be equal to fn, and then by using reflexive property, what I can write fn to be equal to theta of fn. That means I can replace log n with theta of log n. Okay, so this log n which is there in the recurrence equation, I will replace it with theta of log n in an attempt to convert this recurrence equation into the standard form. Now this step 1 is complete. So after step 1, what we are supposed to do is we are supposed to estimate the values for the coefficients a, b, k and p. Now this is the standard form. So we have converted the recurrence equation into the standard form, and now we are supposed to find out the values for the coefficients a, b, k and p. Okay, and this will be done by simple comparison. So what we find out is that the value of a is equal to root 2, value of b is equal to 2, value of k is equal to 0. Why? Because I can write log n to be equal to 1 multiplied by log n. Okay, and this 1 can be written as n to the power 0. So by direct comparison, what we find out is that the value of k is equal to 0 and the value of p is equal to 1, right? Now that we have obtained the values for the coefficients a, b, k and p, the next step involves to find out if these values actually conform to the different constraints. Now these are the constraints that are required for a problem to be solved by using Master's theorem, and we will check one by one if these constraints are satisfied. So value of a should be greater than or equal to 1. In our case, it is equal to root 2. That means constraint 1 is satisfied. Similarly, the value of b should be greater than 1. In our case, it is equal to 2, which means constraint 2 is also satisfied. Third constraint says that the value of k should be greater than or equal to 0. In our case, it is equal to 0, which means that constraint is also satisfied. In the fourth constraint, p should be a real number, which is in our case it is equal to 1. That means this constraint is also satisfied. So by this inspection, what we find out is that all these four constraints are obeyed by these values, and that is why our problem qualifies to be solved by using Master's theorem. Okay. So in the next step, what we will be doing is we will be comparing the value of a with b raised to the power k. So we know that the value of a is equal to root 2, that is roughly 1.4. Okay, and the value of b raised to the power k is equal to 2 to the power 0. I'm simply putting the values for b and k, and what I get, b raised to the power k is equal to 1. So by comparison, what we find out is that the value of a, that is equal to 1.4, is greater than value of b raised to the power k, that is equal to 1, right? So this means a problem conforms to case 1. Okay, so in case 1, what is the solution? If the problem or the recurrence equation lies in case 1, the time complexity for that it is given by theta of n raised to the power log a base p. Okay, this is the time complexity for the recurrence equation that satisfies all the constraints of Master's theorem and which lies in case 1. Okay, so this should be our answer, and what we will be doing the next step is I will simply be putting the values. So n raised to the power log, what is a? The value of a is equal to root 2, and what is value of b? Value of b is equal to 2. Okay, so this is our time complexity for the recurrence equation that was given to us, and we have been able to find out by using Master's theorem. Okay, so this is our answer. So I hope you have followed through the different steps involved in computing the time complexity for the recurrence equation. We now come to the end of this video, and we will be joining shortly.